Hello and welcome to part 2 of Newly presentation series on using graph databases in identity and access management systems. My name is Hadi Amadi and I'm working with Newly Identity Solution Architects. In the previous video, I discussed graph databases and explained about our demo OpenAM extension plugin that leverages graph databases to realize a client-based access control mechanism. In this video, I'm going to show you how this plugin is configured and how it actually works in a real implementation. For the demo, I installed and configured ForgeRock OpenAM 12 and Tomcat 7, Neo4j 2.2.1 community version, Apache 2.4 as our web server, and OpenAM policy agent to protect it. I also deployed our two custom plugins into OpenAM lib directory and followed ForgeRock documentation to introduce them to OpenAM. Let me show you how the OpenAM access control policy is configured. I go to access control on the OpenAM console, then the role, then policies, where I can see the web agent service application, which is OpenAM default. I click on it and I've already created a policy that uses my plugin. Here I show you how it's configured. So I gave an arbitrary name to this policy, that's client type access port 80. I protect every resource under my Apache web server at port 80, and I allow get and post methods to any authenticated user that meets the environment condition. For the environment condition, I have client type authentication, which is configured as follows. I've set the capture window to be 2 hours. The trusted IP min auth history to be 1. It means that only one authentication is enough for an IP to be trusted by the user. 2 users authenticated from an IP are enough to make the IP public, and 5 authentication failures are enough to make an IP adversarial. For the advices, I prompt any user coming from a private IP to go and authenticate against a private chain, and users coming from public IP to go and authenticate against public chain. For adversarial IPs, I don't provide any advice, and I'll leave this box empty, so I deny access to any user coming from such an IP. This is pretty much the configuration of the policy. Now, I'll show you what my private chain and public chain configuration looks like. Go to console and authentication, where I have created these 2 custom chains. I configure private chain to be simply an HMAC one-time password module, and the public chain to include an OAuth to Gmail module. Now the 2 chains are different so that I can distinguish the behavior and explain well how the plugin works. Now let's see how the access management system works. Before everything, I should say I'm using an IP which has made no history whatsoever in the graph database within the capture window. Now Dave wants to access the home page of the Apache web server. He'll be redirected to authenticate against OpenAM. After being authenticated, they will be redirected or prompted for a private authentication chain. This is simply because the IP that Dave is now trying to authenticate from is a private IP but not yet trusted. So they request a one-time password, and having received a response, it will enter that password, submits it, and gets into the system so it can see the resource. Now let's log out of Dave's account and see what has happened to the graph. This query shows the last two authentication events of Dave. If I launch the query again, I can see that Dave has made the two authentications different times using the same IP. This authentication event has been simply the OpenAM access control authentication, and this one, which is the last authentication of Dave's, is forced by the access control plugin. Now, if I click on this use client relationship between the user and the client node, I can see that Dave's done two authentications, one of which has been through private chain. This authentication is enough, according to our plugin configuration, for the IP to be trusted by Dave. Now, if Dave goes back and tries to access the resource again, after being authenticated through the username and password credentials, Dave can have direct access to the page without any further steps of authentication being required. This is because now the IP is a trusted IP. Perfect. So Dave logs out of his account to kill the session. Now if a second user, like Hadi, tries to use this same IP of workstation to access that page, after giving it credentials, as soon as Hadi authenticates, this IP becomes a public IP because there's now two users using this IP. So that's why Hadi is prompted to authenticate against a public chain, which is an OAuth to Gmail. Now, Hadi needs to provide his email and password. And by giving this email password through an OAuth to authentication, Hadi can get access to the page. Okay, now let's log out of Hadi's account as well and go back to the graph interface and see what's happened to the client node. This software query shows the connected users to a client node. So by knowing that my client IP is this, and the time of authentication, or the current time, let's say, is minute, or I could say it's hour 22 of day 16 of June. I can launch the query and see what is the client status. So as you can see, there's two different user IDs that are trying to use the same client at this hour, and that's why the IP has become a public IP according to our plugin configuration. Okay, now let's go to the last scenario. Consider the fact that this IP might be used to authenticate against a system, but may result in different failure attempts. Assume that somebody tries to access a system, but maybe using Dave's account with some wrong password. Maybe Hadi's account with some wrong password too. There could be also invalid or fake user IDs as well. Maybe somebody tries root access, or admin access, or even a totally random user and password. So I guess we've already done 5 authentication failures. Let's go and confirm it in the graph. So if I launch this Cypher query again, I can see that there's 5 users, like invalid and valid user IDs, that have been trying to authenticate from this IP. I can even make this query a little more accurate by trying to calculate those values that I care for. So what I can do is I can take the mathematics of this query that I already have saved, and throw it against my graph. See how it works. This query, as you can see, says there's a total of 10 authentication attempts from this IP from like 5 different users, and there's 5 failures. So according to our plugin, this IP is now an adversarial IP. Okay, so assume that now Dave comes back to the system and wants to access the homepage of our Apache web server, trying to authenticate using a correct set of username and password. However, there's no access given to Dave's because this IP is now adversarial, and any access to the protected resources will be denied during the capture window. To conclude, we presented the client-based access control demo to show the effectiveness of graph databases for implementing policies in OpenAM. This is to be viewed as a starting point with various interesting directions. The post-authentication data can be used to enforce more complex policies or even to serve other AM areas such as location-based access control, detection of denial of service or intrusion attacks, auditing, and many more. I would also like to note that OpenAM already performs adaptive authentication and does it very well. Newly has explored an expanded use case that extends beyond authentication and looks to achieve authorization rules based on users' authentication history, which is best usable if stored in a graph database. So Newly is complementing the existing processes of ForgeRock OpenAM and opens the door to even more possibilities for authentication, authorization, and auditing. In a broader picture, Newly is looking at how to address the question of managing an ever-expanding volume of identities driven by the IoT. In our own research, we started investigating the use of graph databases as a possible alternative repository for OpenAM and OpenIDM products. It's proven to be a very fruitful path of research. Thank you for watching this presentation. If you have questions or comments about this presentation and Newly's research on using graph in the IAM world, please do not hesitate to contact us.